Good evening to all. So, beta, what you talked in the last lecture? Beta, what I taught in the last lecture?
Sir, you taught us the
What,
method
beta?
of differentiation and gave various definitions.
Okay. Okay. So, beta, in last lecture, I will discuss physical meaning, mathematical meaning, and geometrical meaning. Okay. So today, beta, we will discuss one important point here. This is the observation. This is the observation one. Okay. So let's y is equal to fx is a given function, then its derivative with respect to x, then its derivative with respect to x can be given as dy by dx. Okay, so you can also write as like as that. Okay, this is also equal to limit s tending towards 0 f of x plus h minus the fx upon h. Okay, okay, beta. So let's suppose some simple changes. Let's say this is s. Let's say this is let's say delta x. Delta x tending to 0. So simply beta f of x plus delta x minus fx divided by delta x. So basically, guys, just to observe the situation. So what is my motto is? Let's suppose beta, this is the curve. Let's say, let's suppose, let's say this is the curve y is equal to fx. Okay, let's suppose this is the curve y is equal to fx. Got it? And one important thing is that here, that let's say this is point A, this is point B. So beta, let's say this is called, let's say this is called x let's say this is called, let's say beta, this is x plus delta x So guys, just let me know one important thing here. What is the distance between this length? What is the length of this thing? What is the this length is what? This length is simply delta x. Okay, okay now. And let's suppose guys, this is let's say guys from this thing. Let's suppose this length is what? This length is what? Beta, this length is what? Let's say this length is fx, and let's assume, let's say this length is up to this length is what? This length is what? This is beta f of x plus delta x. I think beta this length is what? This length is simply what? This length is simply delta y. Okay. Oh, this is delta y, but this length is delta y, no? This length. Okay. So, but delta y means what? Sir, this is the changes. Okay. But x plus delta y2 minus y1. Y2 minus y1. Okay, now this is the better change in y. This length is better. How to calculate this length? The difference of y, change in y. So, better this length is what? So, this is equal to limit delta x tending to 0. This is delta y, okay, upon delta x. Delta x. This is delta y upon delta x. So, guys, how's the delta y? So, this is simply change in y. So, change in y is represented as delta y. Okay. So, this is delta y by delta x is 1. So, this is simply average rate of change of y with respect to x. But whenever delta x tending to 0, this is finally what? This is instantaneous rate of change of y with respect to x. And this is also equals to beta. This is also equals to f plus x. Okay. And this is equals to differentiation of y. So that is the final explanation. This is the final explanation. So basically, let the y is equal to fx is a given function. Then its derivative with respect to x. Then its derivative with respect to x can be given as dy by dx. And you can simply say beta. You can simply say differentiation of fx with respect to x. Okay. Simply differentiation of fx with respect to x. Yeah, limit s tending to 0, f of x plus s minus fx upon s. Okay. Yeah, limit delta x tending to 0. So we have to consider different manipuration here, and then we go. This is clear, beta? Any doubt? Beta, this is clear now.
Yes, sir.
Okay. One important thing, differentiation of this thing is also, you can also indicate, that is the capital D something. This is the representation of differentiation. Okay, now. So note number 1. Note 1 is to find derivative of a function to find derivative of a function by evaluating the limit given in 1 is called first principle or AV initio. But one is this one. One is this one. Okay. This is called AV initio. Okay. Note number 2. This is called differential operator. This is called differential operator of first order with respect to x. Okay. Note number 3. Delta y upon delta x is average rate of change, average rate change of y with respect to x when x is when x is changed by the quantity delta x and limit delta x tending to 0, delta y upon delta x is instantaneous rate of change of y with respect to x. So I think, guys, this is clear to all. Any doubt here? Any switch? Okay. That is the fundamental observation about the differentiation. Okay. This is the point number 2. So, guys, point number 1 is that to find the derivative of a function by evaluating the limit given in equation 1, given in note number 1, is called first principle or AB initio, or you can also say delta method. Okay, guys, this is also called delta method. Okay, delta method. Second thing is that the differentiation of something is equal to ddx of something, and this is called differential operator of first order with respect to x. Okay, first order differentiation. Guys, first order differences. Note number 3 is that delta y upon delta x is average rate of change of y with respect to x when x is changed by the quantity delta x. So I think no need of any explanation here. Simply x changed by the delta x. So simply and limit extending to 0. Delta y by delta x is instantaneous rate of change of y with respect to x. Now, right? Delta extending to 0 means what? Delta extending to 0 means actually, guys, I'm just introducing this thing. 1 minute. So, note number 4 is that note number 4. This is dy by dx also gives slope of tangent. Dy dx also gives beta slope of tangent. Already discussed with you. Note 5. Beta d alpha upon d beta is also equals to limit delta beta tending to 0, delta alpha upon delta beta. Okay, this is clear now? This is clear. Note number 6. Simply beta dy by dx is equal to limit delta x tending to 0, delta y upon delta x. Okay, okay, guys, just consider one important thing. Let's say this is the curve. Let's say this is the curve. Y is equal to fx, and we observe some important point A and another point B. This is A, and this is B. So, my dear student, this is okay. So, this is the perpendicular to each other. Okay. So, beta, this length, this is beta. This is what? This is beta. This is delta x, and this is delta y. So, guys, my dear student, one important thing is that let's suppose delta x tending to 0. Guys, delta x tending to 0. What is the meaning here? But delta x is tending to 0. It means totally clear that, sir, delta b, delta y also tending to 0. Okay. Very beta, just consider when we just beta close the just beta simply delta x very tending to 0. N is beta tending to 0. This point is also beta here. Okay. At one time beta, this point is totally overlap the point A. One minute. Very difficult to make curve. Okay. So this is clear to all. Okay. So I think delta x tending to 0, so delta y tending to 0. So I think this is clear to all. So whenever the delta x tending to 0, this is what delta y tending to 0. So my dear student, just one important thing. Let's say, right, guys, 3 into, guys, 1 minute, 3 by 2. Let's suppose. Let's suppose 3 by 2. So, but a 3 by 2 is also written as 3 into 1 by 2. Any problem? Any problem? No problem. Because but a delta y upon delta x is a ratio. Okay. So, sir, this is ratio or not? But this is not a ratio. But d by dx is operator. We have to never block the d alag way, d is another way, and d is another way. Never. This is never happened. Yeah. But delta y upon delta x is a ratio, and you can also break separately. So, my dear student, one important thing is that here. So 3 by 2 is also written as 3 upon 1 by 2. So this quantity is also written as, let's say this is delta x tending to 0. This is also written as 1 upon delta x upon delta y. Effectively, this is nothing, this is similar to this. Okay. Any doubt? No, sir. No, no. So guys, whenever delta x tending to 0, it's totally clear that delta y also tending to 0. So means what? This sir means one thing is also clear from here. Sir, here limit delta y tending to 0, 1 upon delta x upon delta y. That is clear now? Guys, as I also write here as if dy by dx exists, then limit delta x tending to 0, delta y upon delta x must also exist for which delta y tending to 0. Okay, this is explanation for that one. So guys, this is also clearly limit, but this is also equals to, you can also write in that way. These are 1 upon limit delta y tending to 0, delta x upon delta y. Yes, no problem. We can also write. Sure. So, guys, whenever limit delta y tending to 0, delta x upon delta y, that is equals to dy upon dx. Okay. How? Are beta, simple explanation. Delta y upon delta x tending to 0, that is equal to dy by dx. Okay. So delta y tending to 0, delta y tending to 0, delta x upon delta y is also equals to d is also equals to delta is also equal to dx by dy. No, sorry, dx by dy is also equal to dx by dy. Dx by dy. Okay. So guys, what you observe from here? Sir, we observe is sir dy by dx is inversely reciprocal of dx upon dy. So you guys also think that while writing this such thing here, this is simply reciprocal form. No beta. I'm not all. Okay. I'm not a all. Okay. I'm a people. So I'm not a make fool to you. Actually, I'm just giving the proper explanation because no one teacher give the proper explanation in this thing. 90% teacher are beta fake in this field. Okay. So no have any idea to how to determine the things from the basic to advanced level. It's simply beta dy dx is reciprocal to dx by dy. How this is possible? But this is the explanation. And almost 2 to 3 times IIT-JEE Advanced asks the simple application-based question in IIT-JEE Advanced paper. Okay. So beta dy by dx is nothing is simple. Dy by dx from here dy by dx into dx by dy. That is equal to 1. That is equal to 1. Okay, that is equal to 1. So that is the important observation in front of you, which I discuss. Okay. Okay, now. So guys, just to observe the statement and just to observe the manipulation and having it out, just ask me. First, beta, observe this explanation because that is very important thing, beta. Okay, and that is very important concept also. Okay, beta, any doubt?
So,
Yes.
so that means x tends to 0. It's any value which is either greater than 0 or less than 0, right? Any variable less than.
Beta, what one? Sorry, x tending to.
Sir, x tends to 0 means that any variable which is either less than 0 or more than 0, right? Any number. With
Yeah,
respect
beta, x is tending to 0 means that 1 minute. Beta, x is, let's suppose h na beta h s tending to 0 means that h is not exactly 0. H is not exactly 0. But h is approximately 0. Okay. So one thing is clear. One thing is clear. One. So beta, h is not equal to 0. H should be positive, but h is, yeah, matlab h is positive surely, but h is not equals to 0. Matlab h is approximately 0. Yeah, h is also less than 0 and h is also greater than 0, but very minute change, not exactly. Okay, yeah, you are also correct. Okay, beta. Any doubt, beta? Any doubt? Okay. But I just check once. Any doubt? Because that is very important thing, and you have to also consider these things in the first time. That's good. No doubt. Just let me know. Note 1, note 2, note 3. Rituraj, Samita, BM Ajay. Any doubt?
What out of my side, sir?
Lock here. Lock beta, any doubt?
No doubt, sir.
Okay. So I'm just starting the question. Question is that by using first principle method, find differentiation of fx is equal to xx square. So guys, you know very well, sir, first principle is, so first principle is simply f dash x is equal to limit h is tending to 0, f of x plus h minus f of x upon h. Okay, so limit x tending to 0, fx is equal to xx square. So simply x plus h ka whole square minus xx square and divided by h. So using a square minus b square, simply get x plus h minus x plus h plus x and upon h. So what we observe here, beta, x get cancelled. So limit s tending to 0. This is h into 2x plus h upon ka h. So this h and this h get cancelled. So limit h is tending to 0, 2x plus h, and guys, that's totally related to x plus h. So beta, h is tending to 0. So this quantity will be always 0. So the final answer will be 2x. So by the helping of first principle, you have to prove any differentiation formula by this method. Sir, differentiation of sin x is how can you say differentiation of sin x is cos x? So by the using first principle, we have to prove that differentiation of sin x is equal to cos x. So basically, beta, that is the very important approach, and this is approach is called first principle method, yeah, delta method, yeah, ab initio. Okay, so I think beta, this is clear to all. Okay. Beta, this is clear, huh? Any doubt? Any problem? No doubt. Okay. Guys, try to solve this thing. Okay, do itself. Try to solve it. Huh? Just better solve it fastly. Done. Beta, any reply? Guys, what happened? Simple beta. F of x plus x minus f of x upon h. Simply use na. Limit s tending to 0. Sin x plus h minus sin x divided by h divided by h. So you have to simply sin c minus sin d formula. Beta, what is the formula of sin c minus sin d? Guys, do you know? Sin c minus sin d. Oh, very simple formula, beta. Sin c minus sin d. So simply, beta, sin c minus sin d. So simply what? Sin c minus sin d is 2 sin, है ना? 2 sin c minus d by 2 cos c plus d by 2. Okay, 2 sin h by 2 Okay, into cos x plus h by 2. Okay, beta, and divided by divided by h divided by h. Okay, so do you know very well in limit x tending to 0, sine x upon x is equals to 1. This is class 11 formula of limit. Class 11th limit formula. Limit x tending to 0, sine x upon x is 1. But here x is tending to 0, and this is h by 2. Guys, this is h by 2. So simply beta, just to multiply with 2, divide with 2. Okay. So from this thing is what? This thing is 1. Okay, 1. So finally, limit h is tending to 0. This is, and 2 get cancelled. Simply beta 1 cos x plus h by 2. Okay, and h is tending towards 0. So simply you can consider beta this is 0. Okay, so finally this is equal to 1 cos x. This is your answer. Going to use very simple formula. Limit x tending to 0, sine x by x is 1. Got it? Beta, tell me. Clear now? So, beta, we can we can we can differentiate any function by using first principle method or delta method or AB initial. We can solve any question by this first principle. Any question. Okay. So simply beta, just one more question. Only one question. Y is equal to 10x. So just differentiate it by the first principle. Just differentiate it by first principle. First beta. काम करेंगे बेटा got it or not? Simply dy by dx is equal to limit s tending to 0. Yeah, sec s per x. Correct answer. F of x plus h minus fx upon h. That is equal to simply limit s tending to 0, tan x plus h minus tan x upon h. So do you know very well tan c minus tan d? Guys, do you know tan a minus tan b? So guys, formula is that. One important formula is just class 11 formula, tan a minus b. So tan a minus b is tan a minus tan b upon 1 plus tan a into tan. So finally, beta, simply tan a minus tan a is equal to what? So tan a minus tan b is equal to tan a minus b into 1 plus tan a into tan b. So using this result, so simply beta, simply what we get here, simply limit s tending to 0 tan a minus b. So tan a minus b simply tan of x plus h minus x into 1 plus tan x into tan x plus h or divided by h divided by h simply. So guys, here simply limit s tending to 0. This is what? This is tan x cancel tan h into s tending to 0 here. So simply tan x into tan x is 1 plus tan square x. Okay, and upon h. So one important formula in limit h is tending to 0, limit x tending to 0, limit x tending to 0, tan x upon x is equal to 1. So simply beta, this is 1. So finally you get 1 plus tan square x, and this is finally equals to x. That is your answer. So by this method, you can differentiate any question. But we don't use this type of method because that is too much lengthy and very timeable, very time taking method. Okay, now that's will not take more time. So I think beta, just giving some homework to you. Try to solve because this is not a tough question, but slightly lengthy by using first principle method to find facets where first question where y is equal to e to the power x. Question number 2 is y is equal to e to the power 2x y is equal to a to the power x extra, y is equal to under root of sin x. So this is your homework question, beta. Solve it from home. And okay. So beta, thank you for today. Well, beta, 3 lectures is remaining in differentiation. And after 3 lectures, differentiation is completed. Okay. Thank you for today, beta.
Thank you, sir.
Okay, beta.